This is the solar system, recreated entirely in C++ with OpenGL, powered by real physics and math equations to demonstrate gravity, astrophysics, and more. But without further ado, let's see how it works. To start, well, where do we even start? Well, in order to start, we need to initialize GLFLW, then create a blank window. Pretty cool. Now, let's start rendering. If you're familiar with rendering models, just in general, then in order to render pretty much anything, we basically have to use triangles. If you don't know, anything in the world can be rendered by triangles. Like, look, if we want to render this circle here, which we'll have to do in a little bit, we can easily add in some triangles, angle them properly, and boom, there's somewhat of a circle. We can quickly start by writing a vertex data table to draw a triangle, code, and then boom, a triangle. Within minutes, I got my first circle. Pretty cool, right? Well, actually no, we can do much better than this. With a camera to turn this 2D circle into a 2D circle with a camera. And in order to do this, we need to use an API GLM, which in simple terms just helps us not write a lot of math. So, long story short, it's pretty good. By including the GLM matrices header file and the type PTR into our project, doing some quick code, and we get a camera. But it's still not 3D. And in order to turn it into 3D, we need to turn this circle into a sphere. By using theta, pi, and phi to draw latitude, longitude onto our sphere, we can easily turn that into renderable data. And after running the project, we get a sphere. Though it does kind of just look like a circle facing to the camera, but it's still a sphere. We can fix this illusion later by adding ray tracing and pretty cool lighting. Now, gravity. In simulations, people usually represent gravity as a force in simulations because it's simple and it works pretty good. But that's not what gravity actually is. Einstein's theory of relativity showed that gravity isn't a force at all. It's matter curving spacetime, and the bigger masses create stronger curves. We can represent this in a 2D grid, though we'll do it later. For now, even though gravity is not a force, we can still represent it as a force in our simulation. A formula we can use is F equals G times M1 times M2 divided by R squared. Using this, we can easily add gravity into our simulation, and when we run it, it works pretty good. Now, to make this more realistic, we can add the 2D grid I just mentioned to help represent Einstein's theory of relativity. To do this, we have to create a grid and then use a formula to change the y of each vertex based on the curvature of the object it's producing. Now, if we run it, it does not work. But if we fix it and we add the sun, the first 5 planets, set their masses, and add some cool lighting or ray tracing, I'm pretty sure, to make it look more realistic, it works fantastically. This was a really fun project to make, so if you've enjoyed this video, please leave a like, subscribe, and have a fantastic day.